Wizard of West LA here. Today we're going to take a look at an oscilloscope. There are a lot of different types of oscilloscopes, and this is just one of the many thousands of types. And what this device does is it like a voltmeter, this will show you a graphical display of voltage change over time, so you can actually watch things as they move through time. And it has various settings. I'm going to show you a basic demonstration of how it works in case you haven't tried one. They're actually very useful for a lot of different projects, and I'm going to be combining some projects on my next videos and showing you how it looks and how you can see what's going on with an oscilloscope. So with the oscilloscope, you have a graph, and the horizontal axis is the time, and then the vertical one shows how high and low voltages go. This one has AC DC switch, and I'm going to run it on AC so you can see a voltage go up, and then it'll also show if a negative if you reverse polarity, which we're going to do. I'm going to put a signal through here that varies. It's a sine curve. It varies positive, and then it will go negative, much like your house current does. And it has arrows where you can adjust a wave and move waves around. But I'm going to show you something really simple of how an oscilloscope works. This one will also show you the frequency. So let me hook something up to it and let's take a look and let's see what it does. Now here are the connectors on an oscilloscope. You have a ground line, which is usually an alligator clip to hook up to ground, and then you have the plus side, and this has a little hook. This has a little hook, or you can also disconnect it and use it with a sharp pin and go through and check circuits. So the best way to understand an oscilloscope is we use this little tool, which is a signal generator, and what this device does is it creates a signal. In this case, you can see a wave. It'll make a wave, and it has a frequency, and I have it at 10 hertz. Now this is very familiar, as the hertz is the same hertz that you use. For example, 440 hertz is A in music. So we're running this really low at 10 hertz, and this has an output like the voltmeter. This has an output like the oscilloscope, which has a plus and minus. So let's hook that up to the oscilloscope and let's take a look. So now as we hook it up to the oscilloscope using plus to plus, minus to minus, look at that, we get a wave. And that is a sine curve wave. And you can actually see what it looks like. And this will give you the frequency, which is 10 hertz. And it gives you how high the voltage goes up, and that's the peak to peak. That's from one top to the other top. Actually, I may be able to, yeah, here we go. So you're looking at one top to the other, peak to peak, so here to here, and this is a 4.96, which is 5 volt signal. Now your voltmeter would show you. Now your voltmeter will just show you the voltage, and it's going to flicker too fast for the voltmeter. This will show you a nice graphical representation. Here's the interesting thing you can do with this real quickly, is you can do horizontal, which changes the time. So if I change the time, see we're at 20, you can see we're at 20 milliseconds. I can raise it up. So I'm going to push the left arrow, and now I'm at 50. And this is by time. 100, and I can keep going. And 200. And then after a while, you're going to look at too many waves per millisecond. And that is measuring each part, each square horizontally is 200 milliseconds. Let's bring it faster. Now this is at 50 milliseconds, so each bar or each square is 50 milliseconds. And I'm going to move it over again. 20 milliseconds. So that's what's happening at 20 milliseconds. Let's say we go vertical, up and down. So this is 1 volt, and you can see the upper left corner, which shows I'm measuring it by 1 volt. Then I can lower it down. Now each bar is 2 volts. And each square going vertical is 5 volts. So I brought it back to 1 volt to show you that that's 1 volt, 2 volts, and then that's a little bit over. So it's about 2.5, which gives you 5 volts. You can see it right. You can see it right there, 5 volts. So 2.5 down and 2.5 up, and that is 5 volts. Now that is too small. 500 millivolts is kind of hard to see. So if I bring it to 5 volts, that is 1 square is 5 volts, and you can kind of see what it's doing there. Now the other thing it offers is you can move waves around to take a look at things. You can change, on this one you can change the mode, and every oscilloscope would do this, and you can move waves around. See? You can move a wave, you can raise it or lower it above that center line for calculations and different things that you want to do. Again, every oscilloscope does this. It's kind of interesting what it does. As electronics have changed, I have an old oscilloscope that is the size of a table that does less than this. It's pretty amazing. And look how small this oscilloscope is because of electronics. Look how small this is. It's about a little smaller height-wise than a phone. But that's what I wanted to show you what it does. Let's change. I'm going to change the waveform on that wave generator to a different type of waveform. Let's change it to a square wave, and let's take a look. So in here I have a choice of waves. I pushed a wave on this, and it has square wave, all different types of waves. Let's try this wave. That's a square wave, and let's see what that does. We'll take a look at it on the scope, and there we go. Look at that. It's a square wave, and I haven't changed anything. It's 5 volts, and it's still 10 megahertz. So I wanted to give you a basic look at what these oscilloscopes do. I have another oscilloscope. I'll put up another video so you can kind of see what these actually do. I'll post a link to this oscilloscope. One reason I have this one, on that upper right corner, you'll see it's 100 megahertz. Some oscilloscopes read 20, some read, actually I have an old one that's 10. This one's 100. I picked it because I can actually run frequency. I run some frequencies under 100 megahertz, and I wanted to look at this on the scope and take a look at the clarity of the signal. And for testing, this will test, that's another video I'm going to do. This will test anything coming out of Arduinos, Raspberry Pis, and you can see signals come out, which is really fascinating. And you can actually see what a series of bits looks like. With this oscilloscope, you can sample bits, and it will give you like 8 bits, and then you can read it going across, and you can actually see the on and off. So I will post another video with that. So hope you had fun with the video, taking a look at what an oscilloscope does. And one extra thing I want to add is on these on these probes, you have a switch on these right here, which actually, where's the switch on this one? Actually, right there. You have a switch, and it says times 1 times, and then you have like 10 times. Those are to run it at higher voltages, and right now we're running only 5 volts. You can run some of these up to 80 volts or more, but you have to change the input, or else you have to change that switch on that thing, or else you burn out the meter. Hope you liked the video. Feel free to give us a thumbs up, and I will be presenting more videos with oscilloscopes and various tools so you can see how to use them. And I'll give you a little tour of this oscilloscope, and like I said, I'll leave you a little link of where I got it. It's a useful tool, very useful for testing and various other things, but it's great being able to see the wave on the meter. So remember, have fun with this and keep on learning.